Today we continue looking at our quadratic functions and our parabolas with part 2 of quadratic applications. And today we are going to talk about vertical motion. In the real world, when you shoot a cannon, or as we'll see in one of our examples, Punkin Chunkin catapult or cannon or something, it's going up and it's going out. We don't have enough sophisticated math skills to talk about how far away it will go. We're only going to worry about how high it goes and how long for it going straight up and down. We're only going to talk about the vertical force vector, not the horizontal forces acting on an object. That will come later in a future course. This is a very basic building block today. In this equation, let's write down what all of these things mean. So the h of t, it's not h times t, means the height at time t. And that is in seconds for this equation. The negative 16 is the acceleration due to gravity on Earth, and it is in feet per second squared. Can anybody tell me why it has to be negative? Why? Because gravity is pulling it down. And so that acceleration, when we talk about vertical, is if it's going up, gravity's slowing it down, so it's trying to pull it back down, and then eventually it does start falling, and gravity's pulling it back down until it hits the ground. And you've probably studied things to know that gravity is stronger and weaker on different surfaces. The moon, Mars, that's why I keep saying on Earth. V sub 0 means initial velocity. It means the velocity at time 0. So at the time when we first start, sometimes that is read V naught, meaning 0. And it is in feet per second. And H naught is the initial height, or the height at time 0. And it is in feet. And yes, we can have vertical motion problems where we talk about meters and minutes. We can have ones where we talk about different places than Earth. If we do that, we will give you the equation for that problem. But if it is feet and seconds and it's Earth, this is actually the physics equation that you work with, and we do expect you to memorize this one. Now, let me put a couple of quick sketches up here of what may be going on. On every single one of these problems, you are expected to draw a sketch. Label your axes. Most of the time, it will be time and height. Sometimes it'll be something a little bit different. If I have a rocket launcher on the ground and I'm firing a rocket straight up, at time 0, it's on the ground. After a certain number of seconds, it's this high. After some more seconds go by, it's this high, and eventually it turns and starts coming back down. What does this point where I just put that dot represent? Wyatt? No. I started on the ground at time 0. This is no longer time 0, so it's not anything to do with what I started with. Yesenia? This is the time that it landed back on the ground, because then the height is back to 0. So does that make sense to everybody, just as you look at that? If the horizontal is time and the vertical is height, that point is sometime, comma, 0. So that's the time when the height from the ground got back to 0. So the time when it landed back on the ground. Sometimes it may not launch from the ground. Maybe I'm standing up on a balcony and I either drop something or I throw something so it goes up and then it turns and comes back down. In that case, if I throw it up first, it might do like that before it gets back down to the ground. If I simply let go of it and drop it, that would have been the vertex, and it would just be going down. It would already be at its max, and then it would simply start going down. Does that much kind of make sense before we get into real examples? All right, there really is such a thing as a Punkin Chunkin competition. They do them with catapults, they do them with cannons, they fire pumpkins, and they see how far away they go. We're only going to talk about how high they go and how long they stay in the air before they hit the ground. Because again, we're not ready for that horizontal component in there. So if I give you this equation, that immediately tells you some things about this. We know the negative 16 is gravity pulling it down towards Earth. That's the acceleration due to gravity. Who remembers what we just said and wrote down? What does the number in front of the t or the x do? Yesenia? That's the initial velocity. Is 880 feet per second. That's how strong that cannon is. That's how fast it blasts out when it immediately leaves the cannon. What about the 70? Who remembers what that represented? Somebody who hasn't answered anything yet. Madeline. That's the initial height. So the starting height is 70 feet above the ground. So maybe that's just how high, maybe the cannon is sitting on the ground and it's just such a huge cannon that that's how high the end of that cannon is when it fires. Maybe it means it's up on some kind of platform before they start launching it. I don't know, but it means we start at 70 feet off the ground. Okay, in these problems, we're going to have an equation or give you enough information you can write the equation. And then there's a bunch of different kinds of questions we may ask. You always need to draw a picture that goes along with the problem and label any points that you need for answering the questions in this problem. So we want to know after how many seconds this will land on the ground. So let's see what I can start off with here for a picture. Am I starting at the ground, at the origin, and shooting it up? No. What should my y-intercept be? I need to start at 70 because my starting height, remember, this is going to be my time. So here's where the time is 0. Here's where the time is so many seconds after we launch. At the time 0, we're at 70 feet high because that's the starting height. It's going to go up and then back down. After how many seconds will it land on the ground? Who can tell me where on the graph I'm interested in? Griff, can you help me? I want to know when it lands on the ground. What point do I need to look at? I need to look at this x-intercept over here to the right. So you guys are going to grab your calculators. Now, there's one trick with the calculator. You can't use t on the calculator. You have to use x, because when you tab, it's going to say f1 of x equals. So you need to enter that as negative 16x squared plus 880x plus 70. And when I did that, I got a real funny looking graph like this. Is anybody else getting something like that? Just kind of looks like a straight line. That means my window is way too small. I'm only looking at this much of the parabola. and it's going up, and so I can't really tell. I've got all of the rest of this I can't see. So I don't know how far I need to go. I could start doing, either way, I'm going to do menu, window zoom. I could start guessing how high do I think I need the X's and Y's to go. Or I could maybe do, you guys know I like zoom fit to get a start. Okay, that's looking better. Now I can see it's not a vertical line. And I have no idea how far out I need to go to the right. I don't know if that 10 is far enough. Anybody want to make a guess of how far I might go? 70? Let's see what happens. Maybe you guessed 100. Different people can guess different things. So window, and this time I'm going to do window settings. X's go across, so I know I want to go farther, so maybe 70. I don't really like that 9,000 very well, just because it's got so many things in there. How high do you think I ought to have to go? 10,000, 15,000, 10,000. Let's see what happens. We can always change it again. And so if we do that, and okay, it's looking better. I do see where it hits the ground, but I don't see the top of it yet, right? So I like to see the top of the vertex of my parabola. So I'm going to change it again. Menu, window zoom, 1 for the window settings. And let's maybe try 15,000 this time. Okay, now I'm happier. I can see the whole thing. Different people will be choosing different ones. If you chose to go to 100 out here, you're going to have a bunch of white space out here where you're not seeing the parabola. So your parabola is going to look like it's steeper. It's just a difference of scale. That's okay. Maybe you went to 20,000, so you have more white space up here. The point is, we can see that the max is in the first quadrant, and we can see this. Now, wait a minute. On my calculator, it looks like it goes through 0, 0. Should I change my graph? No, you have to use your brains on these. This one goes through 0, 70. It does not go through 0, 0. So when you draw your graph, you need to make sure it does not look like it's going through 0, 0. Everybody okay with this much? Okay, have you done menu analyze graph 0 for these coordinates yet? If you haven't, let's go ahead and do those. Does anybody need me to model how to do that? Everybody's comfortable with that part of it? So who can tell me the coordinates when we get, the coordinates for that point over here? Ada? 0.079, and we could have the 4. I'll stop there because I'm almost out of room. And yours actually has a 0 there. Remind me, we'll get to some where it doesn't. So that means that it lands on the ground. After 55.079 seconds. Now, my calculator graph had the parabola going there. Should I also get this x-intercept? Why not? I like that I'm seeing head shaking no. I don't, why not? Well, we know that it started at 70 feet. What about that point that goes back that way, Wyatt? That'll be going back to a negative time, and we don't know how to do that. We may enjoy reading books about time travel, but we don't really know how to do that. Okay, let's see what else this is going to ask us. Will it reach 11,000 feet? Ideas for how I can figure that out. And there are at least 2 ways I can figure that part out. Leah? So one thing I could do, I could find the coordinates of the vertex. And is that y coordinate bigger than 11,000, smaller than 11,000, or exactly 11,000? But it's probably not going to tell me when. So go ahead and find the coordinates of the vertex. And then we'll talk about another way so that we can also find when that's true. So has everybody found the coordinates of the max? Menu analyze graph max? Ethan, you look busy writing. Did you get those coordinates? What'd you get? So is that higher than 11,000? So yes, it reaches, but that doesn't tell me when. Yesenia, did you have an idea of how we can find when? So what I'm going to do is I'm going to enter a horizontal line for y equals 11,000. Let's see, I guess I didn't get my height labeled on this, got the time labeled. So if you do y equals 11,000 or f2 of x equals 11,000, don't get rid of your first equation, just do tab and add a second one. So you get a second line. Does it make sense that it will get to 11,000 feet on the way up to 12,170 and again be at 11,000 on the way back down? So I want you to find both of those. Now it's intersections because you have two lines on the graph. It's not a zero, it's not a max, but it's the intersection points there. So how are we coming on getting those coordinates? Yo-Yo, do you have one of them? Do you need help knowing how to, or you just need a little bit more time to finish? Nicole, you have one of them? Do you know how to? Let me get back to mine because some of you seem to be needing some help with that. So I had my first one, tab. F2 is 11,000, and this is not happy with me touching it. So I'll come over to the computer. So I want to get these two intersection points. So it's menu, analyze graph, 4 for intersection, and I go to the left and the right of that point. Always left first, and there are my coordinates. And then I need you to do menu, analyze graph for the other one. And so let's see, what was I coming up with on that one? 18,949. So this one was 18,949, 18 point, sorry, comma 11,000. And what was this other one? Who's gotten that? Jack, you have the other one? Do you have the coordinates for this intersection? What? How about 5,1, comma 11,000. So it will reach 11,000 feet at 18.949 seconds and 36.051 seconds. Questions there? Okay, we already found the max, so I went ahead and wrote these down while you were doing that. But we need to now write the sentence that explains that in the context of the problem. Remember, the first coordinate is the t, the seconds. And this one is the height in feet. So that means 27.5 seconds and 12,170 feet. So what that means is the pumpkin reaches its maximum height of 12,170 feet after 27.5 seconds from launch. And so we've got to talk about it's the maximum and the height and feet and how many seconds on that time. Any questions there? That is our longest example by far today. The other two are much shorter. Okay, next one. There's a sailor who's going to shoot a flare. If it launches from the water, it would be h of t is negative 16t squared. There's our negative 16. What would the 96 mean? Somebody else who hasn't answered. Cooper, what would the 96 mean? What's the number in front of the t or the x mean? So this means the initial velocity. That's how strong that flare gun shoots it out of there. And what's this blank space about? Explain this to me. What's going on with this zero, Nicole? That's if it starts at the water level. Okay, now let's change the problem a little bit. We've got a bridge that's 220 feet high. That doesn't really have anything to do with firing off the flare, but the sailor isn't going to really be holding the flare gun right at the surface of the water. The sailor's likely in a boat, so that's somewhat up from the surface of the water. And probably every time I've seen movies of somebody shooting a flare, they're holding it up. So between the deck of the boat and how high the sailor's reaching up, 12 feet when it's shot. So we add in the plus 12 here. Okay, let's see what we're supposed to find in this. Will the flare reach a bridge? Well, I can go ahead and start drawing my sketch. Will my y-intercept now, we're using this one. Will the y-intercept be 0, 0? What do you think? Yes, no? Yo-yo, why not? So it needs to be 12, so we're going to start here at 12 and shoot the flare up and it's going to land. So this is going to be our time and this is going to be our height. Now what I don't know is, will the 220 be up here? Will it be right here? Will it be down here where it crosses the parabola twice? So you are going to do new page of a document or clear that screen. You're going to do a new F1 of X. And again, you have to type X's in on the calculator or it won't work. And you'll do a brand new F2 of X is 220. And I'm going to wait to draw that horizontal line till the calculator shows me, does it go up above the whole parabola? Does it go through the vertex of the parabola, or is it low enough to cut through the parabola twice? Emily, do you have your graph drawn? Where is your line? Oh, okay. That's easy. Just tab and then add the 220 in on it. Kit, do you have a line on yours yet? Where does your line go? Totally above? Anybody else getting a line totally above the whole parabola? So I'm going to draw that in and say that's 220. Will the flare hit the bridge? So the people on this bridge are safe. So no, it will not. The flare does not reach the bridge. That's DGE. So I've drawn my graph. I've labeled my axes with T and H. I've put in my starting height and I've put in my 220. Does this problem ask me to find how high the flare does go? Does it ask me to find when the flare hits the water? So I could find those other points and label them, but I don't have to. Everybody good there? Then one last example, and we had to fill some things in on this one. We have a tennis player who's going to hit a tennis ball straight up at a velocity of 40 feet per second. And when she hits the ball, her racket is 3 feet above the floor. That's enough to let us get our equation, and then we'll worry about the rest of it. We know it's y equals negative 16x squared plus something x plus something else, which could be 0 or not. Can you guys help me fill in the missing numbers on this equation that I need to use for this problem? Madeline? Okay, so the initial velocity has to go here. Austin, can you tell me what to put after that? Which is? So everybody good with that equation? So clear your scratch pad or your scratch pad graphing screen, or go to a new page in your document and enter this. And we want to be able to draw a graph of that much. So as usual, this is T, this is H, and I'm starting at 3, and I'm going to hit the ball, and it's going to go up and down, and I'm going to label that 3. This question asks, will it hit the ceiling? How high is the ceiling? 25 feet. So what do I want to do with my graph for that 25 feet? Like a horizontal line like we did on that first one. So f2 of x needs to equal what? 25. So you guys go ahead and do that right now. Again, I don't know, do I draw it all the way above the parabola, just touching the vertex, or low enough to go through the parabola twice? Allie, do you have your line y equals 25 on there? Where does yours go? Does it just barely touch the vertex, or does it go through it twice? Well, it sounds like you need to zoom in. So menu, analyze graph, and then there's one where you can zoom in and move your cursor where it's kind of there close to the vertex, and then hit enter. It crosses twice. Everybody getting one that crosses twice? Anybody else need help zooming in? You could do it with changing your Windows settings, but sometimes Windows zoom in is the fastest way to get there. Yes, no, does everybody have a line that crosses twice? So we're going to show our graph something like this. And you've got to have it where you can clearly tell that if you're starting to find some intersection points. So let's see what this says. So yes, it does hit the ceiling. What point am I looking at for when it hits the ceiling? Who can describe what intersection point I want? Emily? So I'm looking for this one right here. So be sure you have enough space between your vertex and your line that you can isolate this by the time you do the menu analyze graph intersection, so that you can easily get your dotted lines, one on the left and one on the right. And then I want to know the coordinates for that. Leo, what'd you get? Working on that? Anybody need help knowing how to get that? Caleb, what'd you get? So fraction of a second to hit the ceiling, and then that would be comma 25, right? So that means that it hits the ceiling after 0.817 seconds, or 8.817 seconds after she hits it. Now, should I also find this one like we did on that other graph? And why or why not? Why not? it doesn't go through the ceiling. Now, that means once it hits the ceiling, it takes no more time going up. It immediately starts going back down, right? So once it hits the ceiling, it's going to bounce down, and the rest of this model is invalid. I would not really scribble through it on my homework set, but for our discussion, does that make sense to you guys? So we're not going to try to, this isn't going to tell us when it hits the floor because it didn't take time to go on up like the green parabola modeled. It got there faster, sometime less than that. So any questions on what we've been doing today? You need to figure out the equations. Be sure you use X on the calculator and not T. Many times you also need a horizontal line to go in there. Label the points that the problem asks you about, and always label your axes.